Hello, in this video we will learn about a research paper titled Evaluation of Security Metrics for System Security Analysis. The complete citation and link to the paper is given in the description box below. It is known that we cannot build a perfect system which is immune to all kinds of intrusions, because intruders could use large variants of existing tools and methods to hide their identity and tamper with the system. There will always be a possibility of a complex attack being executed successfully against the system. Thus, security evaluation has become a very important part of any system, which is used to calculate the probability of success of an intrusion. The quantitative evaluation of security system aims at developing a system that is scalable and secure. There is a need for a model to predict precisely the location and event time of a possible attack execution. Related works and their limitations. Most of the work done in this field is done to find qualitative metrics to evaluate the security. In case of quantitative metrics, security models help in describing the attack process in detail. They are not sufficient enough to evaluate the efficiency of the underlying security mechanisms. Numerical data provided as input to the model is the attack data, and it could be used to generate quantitative metrics to evaluate the security level. The gap between security domain and the dependability domain is fulfilled by the use of stochastic, pertinet, and Markovian models as tools to implement state-based stochastic models for quantitative analysis. The challenges in designing a suitable stochastic model lie in identifying a suitable distribution function, differentiating and describing relevant activities for design and construction of security models. Motivation. Model-based evaluation and metric-based evaluation are the two evaluation mechanisms which can be used to evaluate system security. System behavior and intruder behavior are modeled using stochastic model by metrics like the initial user state, the system state, and the intermediate transition states. The main goal is to depict internal transactions into a state transition model using probability-based modeling technique. In metric-based evaluation, various metrics like number of services handled, number of open ports, and CPU and memory usage are used to find an occurrence of any serious attack and predict the system state. The proposed approach majorly contributes to how well the attacker action and the administrative response are parameterized for the model over time. The basic model works on the principle of semi-Markov chain model. The proposed model considers the state of a system based on dynamic interaction between the malicious user and the system administrator. Proposed model. The proposed model is based on state transitions between a finite set of states. A state can be defined as an identifiable position of interaction between the system and the user. A modeling method suitable for security evaluation is first identified, and then the model is further fine-tuned to capture all the interaction between the system process and the attacker request. Using the discrete time Markov chain model, the security state is evaluated based on behavioral knowledge. In the diagram alongside, the states represent specific security states. The state S denotes a secure situation and E denotes a failure situation. We define security quantification using various parameters given as inputs to the stochastic model. Process flow. To formulate the assumption needed for the discovery of the vulnerabilities in the system, the actions performed by the attacker are grouped as behavior of the attacker. The response generated by the system are grouped as behavior of the system, and the transient vulnerability period is also calculated. The proposed model is appropriate for this scenario because there exists a certain amount of uncertainty in the actions of the attacker and in the response generated by the system. The proposed stochastic model is capable of describing the dynamic interactions that have happened between the request of the attacker and the response of the system with respect to event time. For the purpose of evaluation of the proposed modeling technique, a DNS spoofing attack is executed and modeled. The process flow is when the attacker performs a DNS spoofing attack and establishes the stochastic model. The system evaluation uses the discrete time Markov chain and a transition probability matrix is formed. The estimate of the success of the attacker and defender is calculated, and thus the evaluation of system security metrics are done. DNS spoofing attack. The DNS spoofing attack executes on the principle of hijacking the trust of a client to share confidential data. This is achieved by multiple steps of a systematic intrusion. Step 1. The attacker tries to identify the IP range of the network by performing enumeration and login attempts. Step 2. Once the attacker acquires a local login, the attacker slowly tries to identify and interrupt the DNS query packet of the victim user for domain address spoofing with a fake IP address. Step 3. After the user receives the response, he will have two DNS server address advertising to provide services. Assuming that both are trusted DNS agents, the user in this situation chooses the nearest DNS and would initiate a TCP connection with spoofed DNS service. Step 4. Once a TCP connection is established, the attacker has direct one-way communication with the victim user and could use this connection to lure the victim to share confidential data by issuing commands or sharing the information with similar attack sources. Step 5. The user believes the fake message and starts transmitting confidential messages to a fake DNS server. Transition probability of the discrete time Markov chain. T represents the transition probabilities available between the transient states, and A represents the transition probabilities between the transient state and the absorbing state. The matrix H is computed by the formula shown here as the inverse of 1 minus T and A. The matrix H contains two values that represent the possible transition probability from the current state to the achievable absorption states F and S. By applying the developed stochastic model, the calculation of mean time is done, and it is the resulting measure for measuring relative security. This security measure helps in attacker action analyzing and characterizes the expected behavior of the attacker. Now let's see how this works. We have an example of an age matrix for 3 transient states. If the attacker initiates the intrusion in process T1, the probability of the attack to be detected and mitigated is 0.81, and it will succeed with the probability of 0.19. This is a state of early detection of an attack, and the system will be secured back. In transient state T2, the defense state has started to monitor, and the chance of an attack execution to succeed is 0.34, and it will be detected and mitigated with the probability of 0.66. If the intrusion process is started in T3, it will be successfully executed with a probability of 0.69, and it will be detected and mitigated with a probability of 0.31. Hence, the chance of attacker's success is more. The transient analysis of security metrics are calculated as shown here, and since the p-value is less than 0.1, the system is stable at the current point. Conclusion. For the purpose of quantitative security evaluation, a deterministic Markov chain-based stochastic model has been developed. Here, the success rate of the attacker is evaluated by dividing the intrusion process into multiple sub-attack phases. At each sub-phase, the likelihood of success of the attacker action is computed. We conducted the DNS spoofing attack at the time of the intervals were obtained using a packet sniffer tool like Wireshark. The request-response communication between the attacker actions and the system actions are displayed by a semi-Markov chain, which is further converted into a discrete time Markov chain. And after analyzing this Markov chain, the security measures have been obtained. Thank you.